So properties of matter is going to be where we start. Guarantee you've had a lot of these throughout your high school career. You've seen some of these things. I mean, I'm always kind of impressed by what you can actually learn when you're in middle school because middle school is just like a crazy time of your life. But they do a good job down there in the middle school in terms of science. So a lot of these things you've seen before. And even at West, you've seen before, okay? So our goal is properties of matter, all right? And we're going to define matter. And matter is kind of like that scientific method thing, where you always get the definition or the steps of the scientific method. One of the first things that you guys encounter in your science classes is the definition of matter. So this class is about matter and how it interacts with other matter and how it interacts with energy. Matter is anything that has mass and takes up space. So kind of stuff, all right? And we're not going to go into like the fancy, crazy level of science where you can kind of go down the YouTube rabbit hole of what matter is versus antimatter versus energy and all that stuff. It's definitely requires a tremendous amount of mathematics to even study that stuff. We're going to keep it simple in here. This is chemistry 1. Matter is anything that has mass and takes up space. So in other words, I like to call it stuff. Okay? Sometimes we forget that things like air is matter. One, because we can't see it. We can kind of feel it, but we can't see it. So there are forms of matter that we sometimes forget about, gases in particular. So in this chapter, and what we're going to start off with is kind of identifying this stuff. The periodic table has a lot of business there. You guys study the periodic table at all? You're aware that it is a thing. Yeah. You're aware there's some stuff on there. Okay. You're not sure what half of that stuff does, which is okay. It's all right. It's fine. We'll play the hits. We'll go through the main things, right? But of these things that we're going to look at in this class, actually, I'll just go here. I have 2 substances on the board, okay? Now, these things look very similar to each other. And if I told you to guess what they were, I bet you could guess which one is which, right? Okay? How can you guess which is which based on that picture? Color, right? If I put that in black and white, would it be as easy? No, it wouldn't, right? So we say, all right, gold. Gold is a golden color. All right. Okay. They look very similar. They're both metallic substances. They have lots of characteristics that define them. What we use there to define what they were is color. So we used a physical property. A physical property is a property of something that can be observed or measured without changing the identity of the matter, without talking about how the matter can change. I'm going to give you guys today some physical properties that we use in chemistry, and I would bet you've heard of some of them, and maybe you've not heard of some of them. I don't know. So when we get to them down the road, you're going to be like, oh yeah, I've heard that word before. A property that can be observed or changed or measured without changing the identity of matter. So like when I say, hey, that gold, it's golden color. I'm not talking about gold's ability to react or not react. I'm just saying and describing gold based on something that doesn't identify its chemical behavior. Okay? When you say the color of something or describe the color of something, it has nothing to do with how it can chemically react. I'll ask you this, is gold reactive? I don't know. Let's do it this way. Is it possible in our world to be fortunate enough to find a piece of gold just in nature? Yeah. It is, right? It is. Because gold can be found in nature by itself, that means it's cool with hanging out by itself, which means that it's not very reactive. Does that make sense to you guys? Okay. We will look at chemical properties next week, and we'll talk about something called potassium. Does anybody have any idea what potassium is? People are like, yeah, it's stuff in bananas. Yeah. Kind of, sort of, all right? Potassium is a metal. It's very, very reactive. And you're not going to walk through nature and just find potassium laying around. Okay, so when we get into chemical stuff, we'll talk about how potassium has chemical properties that defines it. Okay, but today we're just looking at these things based on how it doesn't change. Okay, so here are some of the physical properties I want you guys to be familiar with. Okay, some of these, like I said, you'll know. Some of these, you won't know. Right? So we'll start with the first one, density. Man, people, like when I say people, I'm not just talking about students. I'm talking about humans in general. Make the mistake on trying to describe what density is. For us, and in your classes, density has just been a measurement, right? It's just a measurement. Okay, it's mass over volume, shot through the heart, boom, Mr. McCarville, all that stuff, right? So it's a calculation for us. Density is a physical property that describes the mass of something compared to how much space it takes up, okay? Would you say that styrofoam is very dense, or would you say that it is not very dense at all? Not dense at all, right? Okay. That's because styrofoam doesn't have very much mass per volume that it takes up. Okay. Have you ever gotten your face X-rayed at the dentist office where they throw this big old apron on you? You ever done that? Okay, that's lead. Would you say that apron is dense or not dense? Very dense. Okay. Lead is a metal that has a lot of mass packed into a small area. Okay, so it's always a ratio. We use density to describe what stuff is. So like if it's pure lead, it's always going to have the same density. If it's pure gold, it's always going to have its own density. Gold's actually more dense than lead. Gold's really, really dense. So density is something that we use to describe matter, and you'll see how today. The second way we can describe matter without changing it, excuse me, is the state of matter. The state of matter is the form of matter that it exists as. And it's related to the energy it has associated with it. We'll get into the states of matter in a little bit, but the main ones that we come across and that we deal with are solids, liquids, and gases. We use these to help describe different types of matter. So like, if I had a chunk of gold in this room, and I had a glass of water in this room, you could use the state of matter to describe the differences. Obviously, gold, a chunk of gold is a solid at room temperature, and a glass of water is a liquid at room temperature. So state of matter. These two you've heard of. The next one is conductivity. Conductivity describes the ability of something to transfer electricity, heat, or sound energy. Conductivity is the ability to transfer electricity, heat, or sound. There are some things that are more conductive than others. Chris, can you give me something that's very conductive? Metal. Any type of metal, right? Like metal rods. Metals have a characteristic of being very conductive. Okay? When we cook on a stove, we use pans, pots and pans that are made out of metal. Different various types of metals, and we'll talk about those down the road. Can some metals be more conductive than others? Absolutely. Okay. So let's say we're talking about electricity. You guys know what we use to conduct electricity? Copper. Yeah, we use copper. We use lots of stuff. Copper is kind of the most affordable one, but you know what's better than copper? Silver is better than copper. You know what's better than silver? Gold is really good. But we're not putting gold in our wires. Well, we suck. We could have electricity moving so quickly. Why don't we put gold in our wires? It's expensive, and you guys would come in here and gut this place. All right, so you're like, look at the big ball of gold I have, right? and it's not as easy to find. Okay. The next one, and this one is kind of the main one that people get confused by: boiling and melting points. When you use physical properties, we're talking about something that doesn't change the substance that we're dealing with. Okay. When you boil and melt things, you're not changing the chemical complexity of the substance. You're just changing its state of matter. So boiling and melting point is the temperature of phase change is present. Okay, that's a little bit misleading. We'll learn about. By the way, I'm just going to tell you, I lie to you guys all the time. I'm a liar. I'm going to tell you something, and then like 2 months later, I'm going to go, hey, remember when I told you that? Yeah, that was a bit of a lie. Okay? The reason I lie to you is because there are more complex things that determine states of matter and boiling and melting points, and we'll get to that down the road. Okay? So for right now, let's just assume that temperature is the only thing that affects the state of matter. So boiling and melting points. Solubility. Solubility is how much stuff you can dissolve in another substance. How much stuff you can dissolve in another substance. The amount of substance that can be dissolved in another substance. Let's see here. Let me give you an example. Is sugar soluble in water? Absolutely, right? Absolutely. You guys know that. Is salt soluble in water? Okay. Is a rock that I grab from outside very soluble in water? No, not really, okay? And that's another one of those lies. Yeah, there'll be some stuff that gets in that water, but in general, not really, okay? If you go to fill up your gas in your car, and it's just rained, and you look in the ground, and you see these puddles by the gas pump, and you see like this very pretty colorful rainbow in the water. Has anybody ever seen this? Anybody know what I'm talking about? What's the colorful rainbow of stuff? It's gasoline. Okay? Is gasoline and water, are they very soluble? No. Just like oil and vinegar in like a salad dressing. They're not very soluble. Okay? So if you have salad dressing and you're going to put that on your salad, you have to shake it up, right? Just like a lot of medicines. They're not very soluble, so you have to shake them up. Okay? So solubility is something that we can use to describe. Does sugar change chemically when I dissolve it in water? No, it's still sugar and water, right? Still sugar and water. So it's still a physical property. Okay? Viscosity. Oh, now we're getting to some fancy words. You ever heard of this term before? You know what kind of genre of the world have you heard of this word before? Where do you hear the term viscosity? Science class. Science class is the only place. Never heard of it before?
Syrup.
Syrup? Nice. Syrup.
I heard it on TV.
You're on TV? Usually it's, okay, so like nowadays, you guys don't watch commercials. No, you don't watch, so like it's hard to kind of like, a lot of these terms, a lot of this stuff is on commercials. So like a motor oil commercial is where you'll hear the word viscosity, something like that. Viscosity is the resistance to flow. So the term viscosity means that it's very resistant. If you are very viscous, you don't flow very well. So if you take syrup, cold syrup, and try to pour it, it's really sticky, it doesn't flow very well. Versus water, right, which is less viscous, it just flows, right? So motor oils, anybody here change their own oil? Anybody? All right. Those of you guys that change your own oil, you don't just go to like Walmart and just grab any oil off the shelf, right? Oils usually have different ratings and different viscosities that are aligned with your engines and other things. All right. What's that?
I usually just use vegetable oil.
Nice. Good call. Why does your car smell like French fries? Okay, that's actually people that take diesel engines and can convert the engine a little bit. I think it's a diesel engine. They convert it to cook it using vegetable oil. That was definitely a thing, probably about 10 years ago. Still is. And then people that drive around those like, I smell chicken strips, fries. I don't know what I smell. Okay. All right, malleability. Malleability. Malleability is the ability of a substance to be flat. Think of the things that can bend. Once again, we're talking metals here. Some things are more malleable than others. Some metals are more malleable than others. A very malleable metal that you guys maybe have to deal with day to day is like aluminum. Think about anything that forms a foil. Aluminum foil, very malleable. Gold is like ridiculous. I don't know, you guys have heard. So I ask every year I talk about this, I always ask a class, have you guys ever seen gold leaf or know what gold leaf is?
Yeah.
You ever heard of it? Okay, it's legitimately gold, right? What's weird about it? Super thin. It's very fragile. Could I tear gold leaf very easily?
Yeah.
Absolutely. I don't know. Do you guys know what they use gold leaf for?
Put on stuff.
Put on some decorate. Yeah, they use it for like decorations and stuff like that, right? Because it is gold, but it is super fragile. Gold is one of the most malleable things on Earth. Gold, you can flatten to a sheet that's a few atoms thick. So it definitely has some different weird characteristics. Do you think you could do that with iron or something like that? No, it's malleable, but not as malleable. Okay? So these are some of the scientific physical properties. Now, what do we use these for? Okay? We use these things to describe stuff. We use this stuff to describe the differences. So, for example, gold and silver are both conductive, right? But gold is a little bit different because it has a different color. It has a different boiling point and melting point. It has a better ability to be malleable. It has lots of differences. So we use these things. It has a different density. We use these things to describe this matter and kind of organize this matter. Okay? Now, to go back to phase changes and boiling point. A physical change is when you take this matter and you change it to different states. Like I said, we'll go through the different states. A change in matter from one form to another without changing the chemical properties. When something, when a nail has rust on it, is that a physical property or is that a chemical property? Chemical property, right? Because like that nail is not as good as it was before it had rust on it. Anybody had rust on a car? I used to. Rust is not great for cars because it's very fragile. It's very like it just breaks up. Not that you want to drive a car that has a lot of rust on it. So physical change. Okay. We use physical changes to help identify things. Okay. So if I take two colorless liquids, now obviously, if I said, hey, here's a glass of water, here's a glass of isopropyl alcohol is fancy for rubbing alcohol. Okay? You guys would probably use a totally different property to figure out the difference between the two. If I say, hey, you have to drink one of these, Dyson, you have to drink one of these two glasses. One is water, one is rubbing alcohol. Go. What would you do before you drink? Smell it. Yeah, we would use different properties, right? You're probably not going to go, if I calculate the density of the water, and it's close to one. No, you're just going to go, oh yeah, that's not it. And then you're going to drink the water, right? So in science, we use lots of different properties with specifically physical changes. One thing that's different about rubbing alcohol and water is that rubbing alcohol is easier to boil. Okay? You have 2 cups. One has rubbing alcohol, one has water. You put some heat to them. The one that boils first, assuming the temperatures are similar, is going to be rubbing alcohol. That'll boil at about 80 degrees Celsius, I think, or so. Water boil. What temperature does water boil at in Celsius? 100. Yeah, that's kind of why they designed the Celsius scale. So we use physical changes to help us identify these things as well. Specifically, you guys will know this. If you guys go to college and take chemistry, you're going to deal with that a whole bunch. How many states of matter are there? 3. 4. Plasma. 5. What? Who said that? You said, what is it called? Yes, it's called a Bose-Einstein constant. I'll talk about it in a little bit. Does that really apply to our lives? How's you know that? Because you know stuff, guys. You know stuff. Let's talk about the big 3. All right. We're going to talk about the big 3 here. Yeah, we'll talk about what a Bose-Einstein constant is. All right. Not normally in your textbooks. Okay. These 3 are though: solid, liquid, and gas. All right. But I don't have them up there. So, solid, liquid, gas are the 3 states of matter that we deal with. Actually, I'm going to put main difference between those. We know a solid, a liquid, and gas when we see it, right? Basically, the particles in a solid are closer than a liquid, and the particles in a liquid are more attracted and closer to each other than a gas. Okay? Plasma. What do you got for plasma? No, peace. Go ahead. What's that? They definitely are. So the fuel of stars, basically. So do you guys know what our sun? It's a relatively young star. Do you guys know what's in it? What? It's a gas, but it's not a gas. It's actually plasma because it's super freaking hot. So it's mostly hydrogen and helium. With some, it undergoes something called nuclear fusion. Okay. When you take gases and you get them really hot, now not all plasmas are hot, but when you get most gases really, really hot, it's a plasma. It's basically like an energized gas. Okay. There's a plasma in this room that's not very hot. Yeah, nice. Right there. Those guys. Those lights right there. There's no wire that connects both sides. It uses the gas to transmit the electricity, and when it does, it energizes the gas. So there's really, really hot plasmas, stars, and there's not so hot plasmas, like the gases in those lines. Okay. State of matter, Bose-Einstein condensate. All right. Bose-Einstein condensate. Basically, when you take gases, you get them really, really hot. Stuff gets weird. Okay. Science gets weird. If you take substances and get them really, 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 really cold, stuff gets weird. A Bose-Einstein condensate is when you slow down the movement of a particle to close to absolute zero. When you get to this point, for lack of getting to the science, stuff gets weird. Okay? Now, do we have any uses or in our everyday lives of a Bose-Einstein condensate? Like I said, it's the first time many of you have heard it. No, we don't. Right? We don't. Ooh, I'm thirsty. I want a Bose-Einstein. No, you don't want that. It's close to absolute zero. How do you get those things so dang cold? Well, it's going to sound weird, but they use lasers. You don't think of cold and lasers, do you? No, we think hot with lasers, right? So what they do is, you guys understand that things that move faster are hotter? Like just if I take my hands and move them together, my hands are warm, right? Well, the exact opposite. Particles that move slower are cold. So what they do is they take a substance and they shoot it from different directions with these lasers. And what they basically are doing is getting the particles, instead of moving like this, they're trying to stop it from moving. Now, can they perfectly stop it from moving? They can't, right? There's electrons, there's stuff that's moving in there. But they get it going so slowly that the temperature drops a tremendous amount. And then they use another method to like get rid of the hot particles called evaporative cooling. And it makes something that's really weird. All right, that's my Bose-Einstein condensate thing, right? So I guess some of you learned something today, right? So states of matter, those are the big ones. I am going to stop right there, I think. Let's see here. Yeah, I'm going to stop right there.